Hello everyone. So today, previously we had designed a vending machine successfully, right? So today what we'll do, let's try to design the traffic control system. Yep. So let's see what the question states here first. So we have to design and implement a traffic control system that simulates multiple traffic lights operating concurrently. Yeah. The system should automatically cycle through light states, right? So one is red, another one is yellow and green. We know this. Yep. So the system should automatically cycle through the light states. One is red, another one is yellow, and the third one is green. And we should be able to handle emergency overrides, giving the priority to the selected direction, all within a console-based single file Python demo. Yep, so this is fine. We'll be going with a CLI. We'll not be going with any GUI or UI, right? So we'll be going with a CLI demo, basically. Yep, command line interface demo. Yep, so this is fine. Let's do one thing. First, initially, let's start by collecting the this one functional as well as the non-functional requirements. Yep. So let's do one thing. So first one, let's go with the functional requirements. Yeah. So first thing, we should be able to control the traffic lights, whether it may be red, yellow, as well as the green in each direction. Yep. So this is fine. Next, the second requirement here is we should be able to handle the multiple intersections. Yeah. When I say this one, multiple intersections, meaning here this one demo with one intersection basically. Yeah. So next, the third requirement here is timer based light changes. Timer based light changes. So we are speaking of automatic cycle here. Yep. So next, let's move on with the fourth one. Nothing but allow emergency override. So whether it may be ambulance, this one ambulance detection and other stuff. Yeah. We have to be able to allow the emergency override as well. The fifth one here is log state transitions for monitoring. Log state transitions for monitoring. Yep. So this is fine. These are the functional requirements. Next, let's move on with the non-functional requirements. So here, the first one is high reliability and safety. High reliability as well as safety. We have to maintain high reliability as well as the safety. Next, real time, this one, what do we call responsiveness? Yeah, we have to go with the real time responsiveness. Third one, maintainable and extensible design, right? Example, but the simple example is adding sensors and other stuff, right? So the third one is fine. The fourth one is concurrency safe. Concurrency safe in the sense we have to simulate multiple directions independently. Yep, so this is fine. The fifth one is purely here purely local execution without external DB, right? So we will not be making use of any external DB here. So we are just going with a this one CLI demo, right? So we'll be going with a CLI demo. We'll not be making use of any external DB. We can just go with the in-memory DB. Yeah. So this is fine. Now, next, now we have the functional and non-functional requirements. Yep. So let's move on with the algorithm choice accordingly. Yeah. So algorithm choice. So I'll be going with the state machine plus timer based scheduling actually. This one I found this algorithm actually perfect to this one solve the problem actually, right? Mainly to write the code. Yep. So let's discuss why actually the same thing. So first thing what we'll be doing here, each direction light acts as finite state machine here. Finite state machine in the sense this one FSM, we can just call this one FSM. FSM in the sense each direction light here acts as finite state machine, right? So red to green, green to yellow, and then again yellow to red. It should be we should maintain the loop actually, right? So here in simple terms, it will be actually red to green, green to yellow, and yellow to again red. This one we have to maintain this loop actually. Yeah. So here again, each direction light acts as finite state machine, nothing but the FSM, red to green, green to yellow, yellow to red loop. A main controller coordinates transitions with timers. A main controller coordinates transitions with a timers. So optional emergency interrupts preempt normal flow, right? So this one we have to keep in mind. Basically, one more thing here, the time complexity would lead to big of n, and the space complexity would lead to big of n as well, right? So this is fine. Time complexity is big of n per cycle, and n is nothing but the number of directions we know. And space complexity would lead to big of n as well for tracking states. Yeah, this is fine, man. Next, let's move on with the concurrency as well as the data model discussion. Concurrency as well as the data model discussion, right? So let's move on with the data model. First, each traffic light has current state. It should be having the current state. Either it can be red, either it can be green, or either it can be yellow, right? So also we should be having the durations. So basically dict of state durations, dict of state duration. So this is fine. Next, the name, right? So whether it may be north, east, west, south, anything, right? So the name, right? This is fine. Next, let's move on with the concurrency part as well. Concurrency here, so we will be going with the threading actually. This one simulate actually independent light running concurrently. Yep, so this is fine. Next, a global controller synchronizes timing to maintain the fairness, to maintain the right? So this is it for the concurrency as well as the data modeling. Next, let's do one thing. Let's move on with the main thing, nothing but the UML diagram here, right? So for this particular thing, we will be going with the two classes, namely traffic controller, which is directly dependent on the traffic light, or traffic light, which is directly dependent on the traffic controller. Yeah. So we will be going with lights, which is of type list, and we'll be going with this one, what do we call start cycle helper method. Also, we will be going with a emergency override helper method within the traffic controller. These three things, right? So three methods we'll be going with. Two methods, start cycle as well as the emergency override along with the parameter light. So this is fine. Next, within the traffic light class actually, this is also one of the class, traffic light class, main class actually. So here we'll be going with the name, current state as well as the durations parameter. Along with it, we'll be going with the two helper methods. One is run cycle and another one is set state helper method. Yeah, set state helper method or functions, right? However you call it basically. So as I'm completely, I code mainly my primary this one language for this one. What do we call for the CP or for the lead code and other stuff? I make use of the Java. Usually I call it as helper method or the methods usually, right? So yeah, this is basically we'll be going with the two methods actually, run cycles as well as the set state. We need two methods here, right? So this is fine. So this is going to be the simple. This is going to be simple actually. We have discussed the UML diagram. We will be going with the two classes and the parameters and the methods also we have discussed. What are the methods we'll be making use of, and what are the this one parameters that we'll be making this one using basically these two things. Next, let's do one thing. Let's do one thing. Let's move on with the limitations of the current code. Let's move on with the limitations of current code. Yeah, after writing the code actually. So first, let's do one thing. Let's start writing the code. So let's do one thing. First, let's import here time as well as the threading for the concurrency. Yeah. So these two things. So this is fine. Next, if you observe the UML diagram, so we have as I've said earlier, or as we discussed earlier, we will be going with the two classes mainly, traffic light as well as the traffic controller. Yeah. First, let's write the class traffic light, or let's make use of the class traffic light here. Right. I'll just go with traffic light. So this is fine. So within the traffic light class, first thing, let's go with the initialization part, right? So I'll just go with, sorry, yeah. Let me remove this. Also, I'll just go with name along with the self. So within the initialization part, so let me go with name equals name. So this is fine. The second one is this one, current state actually. I'll just go with current state here. So let me assign this one to initially red actually, red within the strings. So this is fine. Current state. Next, let's go with the durations as discussed. So I'll just go with the durations here. So first green, let's set this one to the 5, right? Let's set this one to the 5. And one more thing. Oh, sorry. 1 second. So this one, so this is fine. The next one is yellow. So this is 2. Let me set this one to the 2. The last one, let me set this one to the this one actually 5. This is fine. Yep. Next, let me go with the cell plot. I'll just go with running here. So this is fine. Let me set this one to the Boolean value true, right? So this is fine. So the next helper method that we'll be going with here is this one, set state actually. I'll just go with set state. Yeah. So I'll just go with self as well as the state. Yeah. So within this helper method set state, let's go with self dot. Uh, Let me go with the current state actually. Let me this one assign this one to the state. And one more thing. So let's go with the print for the interactiveness. So I'll just make use of the string interpolation. Let me start with F here. One more thing here. Let me go with name. Yeah, this is showing. This is fine. Next, what shall I give? I'll just give here light and let me pass the state actually. State is important. Let me pass the state. So this is fine. Next, let's go with a one more helper method named run cycle. Yeah, we have discussed this one. You can just have a look into the UML diagram, right? So this is cycle. So sorry, this is fine. So I'll just go with, sorry, what did I do here? Def. Let me go with run cycle. Let me pass the self here. Right. So within the run cycle, this one helper method, first let me go with simple while loop when running actually. This is fine. So within the while loop, so let me go with simple for loop here for state, and three colors we have to consider. One is green, another one is yellow, and another one is this one. What do we call red? So let me copy this one and let me paste it over here. And the second one is yellow. So let me copy this one as well, paste it over here. So let me leave the space. So this is fine. And final one here, let me go with a red. Yep. So this is also fine. Red. Yeah. So within the for loop, what shall I do? Let me go with self dot set state. This is fine. Of let me pass the state. So this is fine. The next one, let me go with time dot sleep. Time dot sleep of let me go with self dot durations actually. Right. So durations of state. Mm, Let me pass the state here. So this is fine. We are done with this part, right? So we are done with a mainly traffic light class actually. Yeah, right. So next, let's go with another class named traffic controller. Yeah. So I'll just go with traffic uh, controller. So this is fine. So within the traffic controller class, let's go with the initialization part here. Nothing but init. So this is fine. Self is enough. So here I'll just go with self dot lights. We have to consider green, yellow, and red. This red. Right. So I'll just go with the self dot lights here. The array. First, let me call the traffic light here. Traffic light class. So let me go with, sorry, not the this one lights actually. So we have to go with the directions. First, let's go with the north and east, right? Just go with the north here. Or this one simple. This is fine. And also copy this one and let me paste it over here. Instead of north, I'll just go with east this time. So this is fine as well. So next, what shall I do? Let's make use of the threads here, as we have important this one, imported threading actually. Dot threads, assign this one to the empty array. This is fine. So the next step, let's do one thing. Let's go with a simple start cycle helper method. Yeah. So I'll just go with def start cycle. So let me pass self here. So within the helper method or the method start cycle, let me go with a for loop here for ln um, self dot lights. So this is fine. Mm, T, let me assign this one to threading dot thread. Yep, this one. And let me set the target to mm, L dot run cycle. This one. Yep, so this is fine. Next, let's go with a thread factory. Let's append the T to this one, threads actually. Yep. Final step is let's start the thread. I'll just go with start. So this is fine. Next, after successfully writing the start cycle helper method, let's move on with one more helper method. If you remember, if you look at this one, what do we call? Uh, UML diagram. Let's go with the emergency override helper method, right? So I'll just go with def emergency. This one, what do we call? Override. So let me pass self as well as the direction. Yep. So this is fine. So within the helper method emergency override, what shall we do? Let's print something for the interactiveness first. So I'll just go with F because I'll be making use of the, or I'll be going with the string interpolation here. So let me give emergency. Um, so let me make use of something that's visually appealing. Just give me a second here. So let's do one thing. I'll just make use of this symbol actually. Right, so this is fine. You can just Google it and take it. Right, so this is fine. Emergency on this one. Let me pass the direction. Yep, so this is also fine. Let me do one thing. I'll just go with giving priority. Right, so giving priority. Yep, so yeah, let me give slash in here. Right, so let's move on with a for loop here. For light and self dot light here, light, sorry. Within the for loop, if the name, this one, if it is equivalent to the particular direction, then let's set this one. Let's go with the set state green. Else, let's go with the set state red. Yeah. So I'll just go with this one. Light dot name has to show. Yep. So this is fine. We are comparing. I'll just go with the direction. Then I'll just go with light dot set state. This is also fine. Of green. So let me go with a green. So this is fine. Yeah, else this is fine. I'll just go with light dot set state. So this is fine. Else we'll be going with a color red. Yep. So this is fine. So this is it for the code. So this is it for the code. Right. So let me do one thing. We are done with the coding part actually. This one is the simple one, right? So we are done with the coding part. Let's do one thing. I'll just take the demo or example usage from the Google. Just give me a second here. So I'll just paste it over here. So we are just simulating an this one emergency override here. Just set this one to the 6 and we are just calling emergency override helper method here. So this is fine. Then we are going with the demo runtime. This one runtime for a short period here. Time dot sleep. I have set this one to the 10 actually. And yeah, this is just for the interactive purpose, right? So what is the output that we need to get here based on the code that we have written actually? What's the output that we need to get here? Let's discuss the same thing here, right? So before this thing, before checking the output actually, or before running the code, let me tell you. So each traffic light runs on its own thread actually. Yeah, cycling through the states. One is green, another one is yellow, and another one is red, accordingly with the code that we have written. And also the controller, we have went with a class this one, right? Traffic controller actually. The controller manages these lights and it can trigger the emergency overrides as well, right? Again, we are going with a time dot sleep here, right? Time dot sleep here twice in the demo, right? So what is this time dot sleep? Basically, time dot sleep simulates real intervals, right? All operations will be printed live in the console. So we are going with a CLI demo, right? So this is fine. So what's the output that we need to get here? Basically, yep. So 1 second, just give me a second here. Yeah. So first is this one north east. We are considering only north and east, right? So you can just check the code. We have considered only north and east direction. So first this one north east. So here so we have just printed light. So this is fine. So first we have to get green. Next we have to get green. Then we have to get yellow. Then we have to get yellow respectively, right? So then we are just going with this one emergency on the direction giving priority. So emergency on the east actually. So based on this, whatever the output that we have given, whatever the demo that we are considering here, so this one, see, for ln controller dot lights running equals false we have set, right? So this one, and also controller dot emergency override we are considering east actually. Accordingly, with the print statement that we have considered inside the emergency override, the output that we need to get here is emergency on east actually. Emergency on east, this one direction, emergency on east, giving priority, giving priority, right? So dot 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 whatever we have considered in the print actually. Next, again, north and east here, north and east, the same thing, light. So first it will be red. So this one, initially we have set this one to false. First it will be red and the second one will be green, right? So finally we have to get traffic simulation complete. This one, this print statement, yeah. After this one, we have to get traffic simulation complete. So this is the output that we need to get according to the code that we have written. So let's do one thing. Now let me copy the file name. I'll just give here Control J. So yeah, let me type Python followed by the file name.py. Let me hit the enter. Yeah. So here we are getting the wrong output. Yeah, correct output actually. Yep. So I thought it stopped actually. We have given this one, right? Time.slip 6 and this one 10 here. You can just wait for some time. Yeah. So this is working absolutely correct. Yeah. So this is working absolutely correct actually. So it will go on loop actually. Next, you can just go on considering this one. Yep. So see here, first light green, green, yellow, yellow. As per the discussion, this works absolutely correct. And we have to get emergency on east giving priority because we have set this one. Controller dot emergency override east direction east, right? So giving priority. So this one is fine. Next, north light. So we discussed this one. Red, green again. So we are getting northeast again. Red, red. So this one green, right? So in traffic simulation is complete here, right? Next we are getting yellow, yellow, red, red, right? So this is fine. Yep. So we are getting the desired output. We are getting the desired output. So yeah, we are getting the desired output, right? So we have already discussed the output part and we have already discussed the this one as well, coding part as well, whatever the code that we have written. Now, let's move on with the limitations of the code that we have written actually, limitations for the code that we have written basically, right? So yeah, let's discuss the limitations for the code that we have written. So the first thing here is no real sensor or adaptive timing. We are not going with any real sensor, right? So no real sensor or adaptive timing. So this is one of the limitation. So no persistence, right? So this is just temporary, right? So this is fine. A temporary run only actually. Yeah, temporary run only. So next one is threads lack synchronization. Yeah, threads lack synchronization, meaning possible reason a real multi-node setup. Yep, so this is fine. Next, let's move on with the final one, not scalable beyond small demo. We are just considering for the CLI demo, right? So not scalable beyond small demo intersections. Yeah, so these are some of the limitations for the code that we have written. Next, let's move on with the alternative algorithms and the trade-offs. Next, let's move on with the alternative algorithms and uh, trade-offs, right? So the first one here is adaptive AI, nothing but ML based. So this is one of the algorithms that we can go with. So the main advantage or the pro of this one is we can just go with a dynamic adjustment via sensor data. And the trade-off basically it needs data and training, right? So this is one of the algorithms. And the second one is token ring scheduling. So this algorithm it's fair and it uses multi-intersection coordination, right? So we basically the trade-off here is slight latency increase, right? So it increases the latency, right? So this is fine. Next, we can go with the event-driven as well. Event-driven algorithm. Basically, it's async. Uh, as it is async, better performance and non-blocking input-output, right? So, and the trade-off here would be it's more complex to code. It's more complex to code. Yeah, the final one is priority queue-based FSM, right? So this priority queue-based FSM handles emergency as well as the congestion, but it requires fine-tuning, fine-tuned timing. It requires fine-tuned timing. So these are the alternative algorithms. Yeah. So these are some of the alternative algorithms that we can make use of, right? In my case, whatever the algo that I went with, I found that algorithm perfect for this, right? For the demo purpose, right? As per the question. So this is it about the this one, designing a what you call what you call traffic control system, right? Traffic control system, basically. We have successfully designed traffic control system. Yeah. Next, what we'll be doing, we will be designing the ATM machine, right? So for now, this is it. Thanks for watching, guys.